clap, please? Just one clap, please. Thank you. All right, let's get started.
I wanna clap.
All right, welcome to Loop's Demo Day. Hey, we're here. Very exciting.
Hello.
Hello, everybody. Welcome. This came maybe a little sooner than we expected.
Definitely.
I think we all anticipated staying a little more stealth for a while, but after we put up our introductory landing page, things just kind of went wild. It ran through Reddit, it ran through YouTube, it ran through the internet, and so we decided, hey, we better get together and do Demo Day sooner than we expected.
So much interest in the community. We thought it was appropriate to just let you guys know what's all about.
Yes.
Awesome. Well, let's get started. First, I'm going to do the formal part. It's just a little bit of a background on where we are, who we are, where we came from, and then it's going to get a little more informal and conversational. We're going to show what Loop actually does. We're going to show it blending up parts, extruding filament, spooling filament. We're going to print new parts with that filament. So you're going to get to see the whole device actually working, which is what we're really all here for.
Exactly, yeah.
I was also going to come into the future.
Yes, and where we're going.
Exactly, yeah.
Okay, so a little bit about where we are now. We're at a place called the Possible Zone. And the Possible Zone is a 36,000 square foot innovation center based in Boston, Massachusetts. The Possible Zone's mission is to advance economic equity by ensuring young people develop the entrepreneurial spirit, skills, and networks to launch successful careers. Here at the Possible Zone, young adults spark their passions and develop entrepreneurial spirit, key skills and mindsets, networks, in an exciting tuition-free experiential learning program that helps prepare them for lifelong learning and readiness for careers of the future. This is where Loop was born. One of the things we do here at the Possible Zone is to help young adults who are aspiring product managers and entrepreneurs learn the product research, ideation, and development process from the inside out in an experiential, de-risked, well-resourced, scaffolded environment. Things that are provided as part of that scaffolding are a board, a chief business officer, creative director, head of product, industrial designers, product development team, manufacturing partners, web development team. The list is very long. And of course, capital to make all of it happen. And the reason why the Possible Zone makes an investment in new ventures like Loop is to give opportunity to inspiring entrepreneurs and specifically to alumni of the Possible Zone. That's a little introductory information. It sets a good stage for the foundation of the team. Now we want to talk about sort of the key members of the team that are here today. There are members that have made this happen today who are not here. But those who are really focused on product are here today. My name's Sean. I am the Director of Enterprise at the Possible Zone, and my background is in product development and launch, specifically in consumer electronics. Before the Possible Zone, I was head of product at a company called FreeWrite. Look them up, they're cool. They make single-focused writing devices for career writers. And prior to that, I was consulting and running my own businesses in consumer electronics primarily, other consumer products as well. Did about 20 product launches, give or take, before my time at FreeWrite. And now we've got some exciting product launches here that I'm a part of at the Possible Zone. I function as the kind of de facto mentory head of product for all of these different ventures that are being funded by the Possible Zone. So really my role is to act in service to Loop and to the development of Loop and to Loop's customers. As all of our roles are really to act in service to Loop's customers. This is Oye. Oye is participating in TPZ's program that we spoke about, that Ventures program, and is the original ideator of Loop, and is now a co-founder of Loop with the Possible Zone. Now we're going to do these introductions for the rest of the team, and Oye, I would love if you would speak to your experiences and how you came up with the Loop idea, kind of where it originated from and some of your background.
Yeah, for sure. As Sean said, my name is Oye, and my background is in mechanical engineering. So for some years, I worked as a mechanical engineer then I was introduced into the makerspace or the 3D printing world through that. And for a long time, I worked in 3D printing and just really worked in product development, worked at different startups, and just really explored the idea of 3D printing. And from there, that's where the idea of Loop was kind of born. Through my experience with 3D printing, I seen that there was a lot of waste created. Over time, I kept thinking about it, and then eventually the stars aligned. I found out about TPZ, I found out about the venture program, and this is where Loop started to really come into fruition. And that's where we are today. This is Loop version 0.3. As you can see behind us, we have our first prototype. The concept of Loop comes from just the years of experiencing waste when it comes to 3D printing. We as a team wanted to really approach it in a different way. We wanted to create a compact, user-friendly approach that we could use in our own spaces.
Yeah, I remember hearing when Oye first came up with this idea, I remember hearing about it and just being excited by the prospect of being able to, you know, because I'd heard vaguely of other people attempting it, and I knew about sort of industrial processes to do this same thing. Obviously, I knew someone, like filament is being made, so how do they make it?
Yeah.
And, but the prospect of, in my house, that I could do something like this. Obviously, I'm not as deep in the community as the three of you really are. You know, I own a 3D printer and have printed on my printer, but it's really just the basics when I need to. Nothing more exciting than that. You guys are deep in the game, deep in the community. And yeah, just the being so deep, it helped you come up with that idea and really what was missing from people that are attempting to do this right now.
Yeah, for sure. And what was missing from our team at TPZ was these guys right here. And I would love to pass it off to Emilio so he could talk about his role, and then also Connie as well.
Hi everyone, we are Constantine and Emilio. We are part of the product development team for the Loop project. It was brought to our attention that this project was going to start, and we wanted to help. Not only Oye and Sean, but also the Possible Zone. We really believed in the values that they had here, and we wanted to make sure that this was possible. Our expertise, we are both industrial design engineers, and together with the rest of our team, we focused on trying to build this project to ensure that we arrive at a working prototype. From the get-go, I connected really well with the idea of trying to make something that was accessible to everyone. We've been able to see industrial machines that can do recycling, but never to the point that was at a consumer accessible pricing as well. We wanted to make sure that we are able to do that. And through our expertise and our past experience in developing products, process of manufacturing with plastics, and as well launching products, same as Sean, we wanted to make sure that we could participate. So here we are.
And I remember when we first were introduced and we were speaking about the product, I got really, really excited because you've actually worked specifically on an extrusion product before?
Yes. So a couple of years ago, I participated with Precious Plastics, which is a company that specifically focuses in recycling plastic and giving it a new life. So we had some experience into how to work with that, extrusions, also other machines that you could recycle plastic. And yeah, we were super passionate to see that this kind of project was going to get to life.
Yeah, right away, everybody jumped in and we bought up all of the options on the market to study what everybody else is doing, right? And see what's being done right, what's being done wrong, to test different parts of different products that already exist and really create that consumer-friendly product you were speaking about.
We realized that shredding felt clunky. It felt like it was not accessible. We felt that the spooling option was too technical for consumers. We also felt that the extrusion of filament had to be something that someone could easily manage.
And it's also very important that when you 3D print with a filament, it also comes out in the best quality possible. So we wanted to make sure that everyone can enjoy a good 3D printing experience.
So better focus on something that comes out properly rather than trying to fiddle in a really technical way in order to get there.
Yes.
Well said. Some other ones that fit into there.
Yeah,
Okay, those are you
all
categorized.
exactly,
up there. Got it.
exactly.
Yeah. So we got to do the demo.
Hi everyone. As we mentioned, we wanted to show you a full process of the loop recycling system. The first thing that we're going to do is that we're going to shred some plastic. We took one of these pre-printed dragons and we broke it down into small pieces to get a sense of the size of the pieces that we recommend people to break down. It's around this size. It doesn't have to be smaller than this. So that's what we're going to do. We're going to start with. So the first thing that you should do, even before you start shredding, is that you should press the preheat button, which will heat the extrusion system, and you will hear a double beep once it's fully on. It will take about 10 minutes. Then let's start with the shredding. So the first thing that you're going to do is that you're going to remove the shield, you're going to put it to the side, and you're going to unlock the shredder. The shredder looks like a tube, and you start removing the blades through the threads, and this is what we're currently using for blades. These are pre-existing blades. For the final version, we're going to use better ones and our own proprietary version. We just wanted to make sure that we had high quality ones for safety reasons. So we need to scrap these ones. I'm going to put it in. And we're going to start the shredding. I put back the blades. We make sure that it's tight. And we give it a good shake for a good measure. We lock it in. And we put back the sound shield. Once it's locked in place, we press shredding. So while it's shredding, I wanted to make sure that I let you know that what we want to do is that we want to extend the shredding shield all the way down to the motor. Because right now, the noise that you're hearing is mostly just the motor chamber because we have to get some airflow in. For the next version, we want to improve upon what we currently have. So it's just about to finish now. Each shredding process takes about 30 seconds, depending on the amount of volume that you have. You should actually try between 1 to 2 to 3 shreds. So let's remove that. I'm going to remove the main shield and open up the tube. So as you can see, maybe you can put the camera into it. You can see that it's fully broken down and shredded.
Hard to catch focus. We'll see it when it comes out.
Okay, so maybe I can just put it down here. You're going to be able to see it. Maybe that's better.
Yeah.
So I'm just going to let it out. And what we're doing now is that we're putting all the pieces through a filter. This filter, what allows is only pieces that are smaller than 2 millimeters can go to the funnel that's going to feed into the extruder. We also pre-shredded some additional pieces just because we have them and we don't want to waste any plastic. So let me just put that in. And what we do now is that we shake the funnel a bit, and you're going to be able to see that some of them go down. Okay. In the future, we want to have an actual vibrational motor that actually does this for you. It's something very simple to implement, but this is what it looks for now. So we let that in. We lock it in, and we put the shield back on, and we press extrude. So the extruding process occurs back here at the bottom. So just come with me. I'm going to bring the microphone so that you can hear me better. So we're going to let it run for just a couple of minutes to ensure that the filament that's coming out is consistent. Right now, while that's happening, I want to explain a little bit of what's going on. So firstly, we have a couple of fans back here to ensure that the filament, which is actually going to be coming into this tube right here that you see the one that I'm holding with the pliers. So the filament goes into that tube, and while it goes into that tube, it gets cooled down by the fans, and it also gets leveled out with this rod right here. So we let it a couple of seconds. And
So So
What-
right now it's just spooling out. We're just making sure the filament is consistent.
Exactly.
In the future, we're hoping for this to be
All
all
automatic.
automated.
Exactly. As of now, this is how we currently have it. So let's give it, I think it's about ready. So I'm gonna grab this piece down here. I'm gonna cut it and I'm gonna feed it into the hole so that it can start, the puller can start its job. And as you can see, it starts pulling on its own, and it's just in a couple of seconds we're gonna see it come out of the other side, which is the spooling side.
Okay. What happens between where we see it now and where it's going?
So what happens is that it goes through a PFT tube, and it allows for the filament to continue to pull out, and it's just a tube. There's a puller that is pushing the filament up into the tube, and then it will start coming out here so that we can feed it back into the spool. So just give it a couple of seconds. It continues to come out consistently here.
Oh, and I can see the filament has just entered into.
Awesome. So slowly but surely.
And then what's the technique once, at least in this version, once it gets to the spool?
So what we do, as with like every kind of spool, is that we try to fasten the end of the filament into the bottom of the actual spool plastic. It's just about to come out. Just a couple more seconds. And what we're gonna do is that we're just gonna let it spool until we have enough filament to do a 3D print, so that you guys can see the quality of the prints after it has been fully recycled. So we can see it already pop out of here. And I'm gonna let it extrude just a tiny bit more, so that we can. Okay. I would say this is about right. So I'm gonna put it into the hole so that we can do it some tension. And I'm just going to use a little bit of tape to take it here to the side. So now we just let it spool.
So this is the boring part, where we let it spool up.
Yep.
And what comes next? What are we going to show these guys?
So what we want to show you guys next is some 3D prints of this filament, this recycled new filament. We already did some tests. This is a calibration cube.
And these ones we just did today.
We just did it maybe like half an hour ago, and we also did a little toast. You can see that the filament is consistent, and you can also see that it's recycled filament because of the different shades of the color. You can see it here. You can see that it transitions because we used multiple PLAs, and I just wanted to make sure that you guys could see a bit of that. So we're gonna let it sit for a couple of minutes.
And then after it spools up, what's the plan?
Our plan is that we're gonna grab that spool and we're gonna bring it down to the printer. We're gonna print another cube.
Beautiful. All right, now's the boring part, everybody. We'll probably time lapse this just a little bit. We'll get about 10 minutes worth of filament up and bring that to the printer.
You can also come around and see that the filament continues to come out properly, as expected.
And how long would it take to fill a full spool normally in the process?
What we've been measuring until now, it's between an hour to an hour and a half.
For a full spool, so a kilo of spool.
Yeah, 1 kilogram of spool, which is what we've been working with right now.
Awesome. All right, I'll try and set this up so everybody can see the
The gimbal.
The gimbal is not performing very well. Okay, set that up. So you can see the filament come out there. See if I can get this gimbal to do its job.
Yeah. All right, everyone. So firstly, we wanted to mention that because we're going to do a really small print, we wanted to make sure that the filament was as compact as possible. And what we're going to do now is I'm going to cut the filament, and we are going to bring it down to our printer. Actually, I do have to pause it so that I can remove it, so let me just pause. Okay. So I just want to show you how you remove the spools. So the first thing that you should do is that you remove the butterfly screw, which is quite quick, and you slide it out, and we're gonna cut a bit off the top, and we're gonna bring it down to the print shop. So come with me. Okay, let's go. So we're gonna load it back in here.
See if I can see it in there.
Maybe through the other side.
Yeah. Man, this autofocus.
So, oh yeah, maybe you can help me. Because I'm trying to. Oh, okay, I found it.
Got it.
So let me see if I can load it in. Okay, so I'm loading in some filament. Just loading that in. You can see the filament that's starting to come out the tube. I'm gonna put it all the way down there. Okay, should be good to go.
So which tube is the filament coming in through?
So we're putting it through filament tube number 1.
Can we see that up top?
Yeah, maybe you can.
Is this one on the left side here?
Is this one on the left
Ah,
side?
okay. So that's our like brownish, ready.
Yeah, exactly. You can go see back there how it currently looks.
Okay.
So we have I think it's the cube preloaded.
Oh, bring out here.
Yeah, so I think it's just cleaning up.
Doing its normal cleaning.
Yes. And it's already extruding some of the recycled filament. Confirm when the new material extrudes consistently from print core 1. We can see, yes. Let me just remove that bit. Okay. Finishing the procedure. Now it's calibrating. Okay. So I've got to go here and select from USB. I'm gonna scroll down the calibration cube and start print. And maybe we could set it up in this.
Yeah.
This is.
Take a picture of you both.
Yep. Yep. Change it up. Oh, just,
No, just the cube.
Yeah. Should be okay.
All right.
That looks great. The audio? The audio?
Yeah. You can find it. Just swipe up, swipe up, swipe up, swipe up, swipe up, swipe up. It'll be right there.
All right, so it's just finishing. It's about to, might take a second. FabLab Ultimaker. It's taking a second now. I guess it's just letting it cool for a second. Okay. So as you can see, this is a just printed 3D recycled filament with loop. I hope you guys have enjoyed it, and we'll send you some cool other stuff in the coming days. No, I'm not gonna eat it. All right, thank you guys. If you have any questions, let us know. Take care. Bye bye.
Thank you very much, Emilio, for that amazing demonstration of the loop. And I'm going to jump into the changes we're going to see from the loop version 0.3 to the version 1.0, which will be shipping soon in 2025. And I'm going to talk about three main pointers: machine size, sound, and optimization. Now, for machine size, right now in the prototype, as you can see, it's fairly large. Now we've left 50% inside of the machine as dead space for repairing, prototyping purposes. And for the upcoming version, we'll be reducing the size, the height, about 25%. And we've already tested this in a digital environment. We are going to produce the parts that we've digitally tested as the next step. Now for soundproofing, it's very important for us. And it is sadly one of the last parts of the development process, because everything has to be perfect and it requires tooling, machine tooling and precision machining and custom gaskets, for example. And we want to make Loop a true desktop ready machine without the need of earplugs. As if you've seen in the demo today, it is already safe to use when you're next to the machine and you can talk normally, but we want to make sure to go a step beyond that. As of optimization of use, currently, for example, the post-extrusion process isn't ideal. We want to make that as simple as possible. So for Loop version 2 to version 3, we are going to try and make the machine as autonomously as possible, and hopefully eventually hands-free. I'll be passing to Oye.
What's next in our timeline? For us, we're going to be spending the next few months working on perfecting Loop version 1. That includes just improving what Connie said, improving our processes, improving everything that we can in the next few months. So that will be towards the end of quarter 1 in 2025. In quarter 2 of 2025, we'll be contacting our manufacturers to begin the tooling and the manufacturing process. In Q3, we'll be looking forward to shipping out our first version of Loop to customers. And by then, we will be already thinking about version 2. This is an exciting period of our journey. We're excited to have you guys join us. And as we continue to build, we want to continue to keep you in the loop, pun intended.
I wanna say that with version 1, we wanna make sure that everyone who has participated in this initial version, that we hear your feedback. Please feel free to let us know what's your experience with it. And with that, we wanna jump into some of the questions that have been popping up. So let's start with that.
We've been sourcing questions from the community. We put out a newsletter, right, and asked for questions to come in. We looked through YouTube comments, Reddit feeds to find the most common questions and kind of distilled those down to
emails. Yep.
To key points that we should be talking about today. A lot of it we already covered in what was discussed, but we're going to hit on some other ones that maybe weren't covered in earlier explanations. Pricing. How does pricing work? We're in this deposit phase. This is a little bit confusing for some people that haven't participated in deposit structures, pre-order structures before, and so we just want to clarify some things on how that pricing works. It's pretty straightforward. The deposit just holds your place at the lowest retail price that we're promising at this point in time. Just to show your interest, to give us an idea of how many of these units we're actually going to have to produce, because we have to, projecting with something that's so expensive to make requires a lot of faith. We could over order product or under order product, and we don't want to do that.
Think about it this way. Whenever you're doing mass manufacturing of a product, the more units you have, the cheaper the product can be built. So if we have a good estimation of the initial units, we can already arrive to better agreements with our manufacturers and make sure we get it as affordable as possible for you guys.
The price we're promising for deposits now is just under $1,500. And we hope to actually drive that price down in manufacturing. And we believe that we can. For sure, in versions 2, versions 3, we can bring that price down. But things always start, when you're doing it the first time, it's always the most expensive it's ever going to be.
Absolutely.
So this is the highest you will, though you are locking it at the lowest price you can lock it in. As far as future iterations of Loop, this is the most expensive iteration in this format that we will have. The same way if you look at like Bamboo Labs, and you've got a complex version, and then you've got the really simple, what's the name of I wish I was the guy.
PS1?
The PS1.
Thank you. You have the stripped down version that just sits on your desktop and is a few $100s. And then you have the complex, $1,200, $1,300, $1,400
Fully
versions.
automated.
Exactly, right.
That's what we wanted.
So we're really excited about the opportunity of driving price down in the future. But right now, your $100 deposit just locks in that retail price so that you will be able to order right at that price. And for those who have put down the $100 deposit, obviously it will be the price less $100, right? We'll give you a coupon for that discounts you that $100 so that you don't pay that $100 when you put in that order. But if you have a deposit with Loop, and you're on the fence about whether or not you need it, you can ask for a refund. That's completely okay. We are functioning like any other normal company you would buy product from at this stage, even though we are a pre-order company at this moment. So if you need a refund, just reach out, shoot us an email, say, hey, this is my order number, I need a refund, and it'll be processed almost immediately. We have some other questions about pricing, just about what currency are we operating in. Everything's in USD. I don't know how Shopify's policies actually work. We're operating through Shopify, so if you're viewing the product in Canada, for example, I don't know if they show you CAD, but the just under $1,500 price point is in USD, and whether or not it's converted on the version of the site you're viewing, that I'm actually not 100% sure about, but the price is in USD. So if you're trying to convert for yourself how much you're gonna have to pay for it, use USD as the standard. Okay, so we had some questions about what sort of materials can be used on Loop, and I think it's important that we cover those. Loop is not going to be able to you can't just chuck any plastic in Loop and have it extrude perfect filament for you.
Please don't do that.
It's been engineered experiment within reason, but it's been engineered for specific plastics.
Right, the way that we thought about it was that the most common plastics that can be done specifically for 3D printing. So think about your Bamboo Lab, your Gravity machine. What are the most common plastics? ABS, PLA, and PETG. We are also thinking into implementing for other plastics in the future, but we want to make sure that it works with those most common plastics. Think also of the fast PLA that you use for the fast new generation machines.
This is how we learn what to do next with Loop, right? The feedback that we get from people in comments and emails, like that's how we decide what we do next. Because we want to make the best device for you guys. We're here to serve the customers of Loop. We're here to serve the 3D printing community. So please email us. It's hello@makewithloop.com. You can reach out at any time, and it's one of us or another member of our team that will be answering those emails and is currently answering those emails. We try to answer 5 days a week and get most everything out. So if you email us, expect a response within a few days, if not within a few hours, and we'll do our best to make sure we make you as happy as possible. We have questions about what Loop can actually recycle as far as parts, types of parts, size of parts. Obviously, you can't just throw a giant brick of plastic with 100% infill into Loop's canister and expect it to blend. What can and can't Loop actually process?
So we're thinking that you should be able to use, if you print always the samples of benchies, that's about the size of limit that we want to go for. In terms of infill, we're going about to 35%. That should be the limit that the shredder will be able to shred. Of course, you can take bigger parts, break them down and put them into the shredder, but of course, no 100% infill.
So the rule of thumb is anything that support material you can put in, anything that's maybe an old filament that you want to repurpose with this new batch you can put in, and anything less than 35% infill you can put in.
Another question that we got is how long does it actually take to go through the full cycle? Obviously, a full cycle here takes a long time, so we're not showing an entire cycle live because it isn't instant. Can you speak to how long that a cycle actually takes?
You should be able to have a new spool within an hour and a half to 2 hours. The shredding actually occurs really quickly. Every shredding cycle is 30 seconds. Most parts can be fully shredded within 3 cycles, and then the spooling process for a 1 kilogram can be about that time, between 1 hour and a half to 2 hours.
We are engineering Loop to be as durable and to have the longest longevity possible. But there have been questions about the repairability of the device. And those are super valid questions. Obviously, in this community, we have a lot of hands-on DIYers. We have a lot of people that are really looking to build things themselves. That's why 3D printers exist. Oya, can you speak to the repairability plans for Loop in the future?
Yeah, that's a great question. So our goal is to have Loop part of the right to repair community. As DIYers ourselves, we understand how it is and how empowering it is to be able to open up the case and tinker with the machine yourself. So we want to give that and share that power with our community. So if something happens to mess up, you're able to open it up, replace it, or contact us and we'll help you replace it as well.
Another question we got from the community was, where is Loop going to be available when you first ship? Very great question. We're going to start out by covering what we're seeing based on initial deposits as being our biggest market so that we can serve as many customers as possible without overextending ourselves. So first, of course, is the US and North America in general. So Canada, the US, Mexico. Also Europe. So if you're in Europe, woo, you made it to the list, and then the UK as well. Okay, so we already addressed it a little bit. But soundproofing is something that people have a lot of questions about. And Constantine, could you speak a little bit to the soundproofing plans that we have for Loop?
Yes, of course. So we want to use several layers of materials to isolate the sound, as everything is vibration and all the parts are touching each other. We want to create somewhat of it's not really a double chamber, but it is a sort of lid that you will be able to lift up and down, which will cover the entire shredding chamber, and this will reduce the sound greatly, as well as using additional gaskets and, as mentioned, different materials to dampen the sound down. And we want to make it sure that you can be in your office or in your workshop and have a Google meeting, a Skype call, or even a phone call with a person and the machine operating next to you. That's the level of sound that we want to achieve.
Mm. Yeah, that's something we've learned already in testing, that hey, we can have a conversation and we don't have to wear earplugs, right? It's comfortable enough in the space, but we really want to push it to the next level. And right now you can see the sound shield is just over the blending canister.
Yes, exactly.
But then as we were testing, we realized, oh man, the motor itself actually generates quite a bit of the noise. So the plans for the future are to extend the sound shield to actually just
Cover that as well.
yeah, okay. And which is how they, I think we got a little bit of inspiration from walking into health food shops where they make smoothies.
Yeah.
And that's actually how they do it. They have a sound shield that covers the entire device, right?
Yes, correct.
So speaking again to deposits, we have some questions about, okay, I've got my deposit and I'm really excited about Loop. When can I actually put the full money down to confirm my order? And we want to give some time for the depositors so that we really have a great judge of the volume of product that we're going to sell before we make those pre-orders live. And also, we want to inspire the community with confidence to put that full money down. So we want to be at our golden prototype, right? We have our proof of concept prototype, which blends, extrudes and spools new filament that we print with. That's great. Now we want to do those optimizations we talk about. We believe that those optimizations will be done, and we'll have a golden sample to photo and video with come, what is that, early March? Is that the end of Q1?
Yes.
The end of Q1 2025, at which point you'll be able to put down your full price deposit on Loop, rather than your just early entry $100 to secure your spot.
And as we go along the process of iteration and improving the machine, you will see how smoothly things will go, and that will give you more confidence to trust us to buy Loop.
And that's another reason why we wanted to take deposits, is to build a small community that we could send these releases to. When you actually deposit for Loop, and we're just in the process of building our Discord community now, where we'll be releasing a lot more details about the development process. The newsletter has some general stuff, so if you're on the newsletter, that's great. But you'll get a lot more specific content if you're in our Discord community, and the Discord community is only accessible with a deposit.
And we'll make sure as well to include some influencers in the 3D printing community, as that is very important for you guys, as you trust them who make reviews of products, 3D printers and such. And we want to give them all the insights to the process as well. Cut.
Okay.
All right, let's pause this. You're being paused.